Hi, I'm Matthew Schmitz, a design student at UC Berkeley, and I've developed Squeeze, a smart ergonomic grip strengthener. I used to compete in jiu-jitsu and on more than one occasion badly sprained my finger. As part of my physical therapy, rehabbing these injuries and working to prevent future injury, I use different types of grip and finger strengtheners. However, I was always frustrated by these devices because they rarely fit in my hand well. They didn't move the way that fingers naturally move, that is, not all in a straight line. I also used them often when I was walking or talking on the phone, and it was easy to forget how many reps I'd done and not be sure if I was doing my PT correctly. I wanted to design a grip strengthener that would move like my hand and keep me on track for my physical therapy. Not wanting to reinvent the wheel, I started by trying out and taking apart existing grip strengtheners on the market. Here are two such teardowns. In order to create a design that matched my hand, I traced the movement of my fingers on paper. I then began to sketch out a strengthener with springs that matched these ergonomics. I started developing a 3D model in Rhino, but quickly realized that I would need to make many small dimensional adjustments to various surfaces, which was challenging, so I moved to Onshape, a parametric design software similar to SolidWorks, but free for students. I hadn't used it a ton before, but it was pretty easy to pick up after learning Rhino, with the exception of a few quirks. I printed a section of the model to iterate on and test the spring, sliding, and button mechanism. I then expanded this to the full model. I developed the resistance buttons as modular components that could be swapped in and out of the model. This allows for personalization and adjusting individual finger resistance. It also enabled me to rapidly iterate on this mechanism without having to reprint the entire body. To develop rep tracking, I first prototyped with a single button press. This reads the button press as an interrupt, debouncing and incrementing a counter, then writing the output to an OLED. I then expanded to multiple buttons for each finger. The counter resets after a period of inactivity and will roll over when it reaches 100. Here's the full prototype laid out. A Photon 2 powers the OLED and electronics. The most challenging part of this project was iterating on the physical design and ensuring room for every component in the tiny footprint. All of the press and sliding fits took iterations to get the correct dimension. In addition to the modular components, I had to include slots and geometry for various small components like the tactile switches and the tactile switch prongs, and room for mounting an OLED to the face. How could technology like this impact the design of human experiences? I think we're seeing exercise equipment increasingly become intelligent, and rehab and physical therapy is a particular area where tracking and intelligent devices could be useful. From a design and engineering perspective, there is also increased opportunity for personalized design. I modeled this strengthener after the geometry of my own hand, but the design could easily be produced in a custom form factor for any individual. Perhaps in the future, a physical therapist will scan your hand and order you a custom finger strengthener that then uploads data about your rehab progress for her to monitor. This has been an overview of Squeeze, an ergonomic smart grip strengthener designed to move like your hand and keep track of your progress. I hope you enjoyed the presentation. This prototype opens the door for future iterations that could include custom routines, increased personalization, and phone web tracking for monitoring progress over time.